So in this video I will explain you why Ethernet was actually developed, which is one of the protocols on the lowest level of the TCP/IP protocol stack. So let's assume we have one or more computers that want to communicate over a shared medium, and the key to this is the shared medium. They want to exchange information, and the smallest amount of information is, as we all know, 1 bit. So a naive approach that you could do in transferring this 1 bit is you could put a voltage on the cable. So if you do this, several problems arise. One problem that arises is how long do you actually have to put the voltage on the cable? Because if you just start putting the voltage on the cable, there will this electromagnetic wave starting to transfer or propagate through the cable, and you have to ask yourself, how long do I actually have to do this that others can measure this? Another problem that you would get is, who is actually the sender of the data? So let's assume computer A sends a bit of data, at some point in time B receives the data, and then C receives the data, and everyone wonders who actually sent the data, and you cannot figure this out right away. A similar problem that occurs is actually who is the recipient of the data. So if A transfers data, B and C might not know if this data is actually for them. And of course, if you have a shared medium, another big problem is who is actually supposed to use the medium. So if A starts to transfer some data, at some point in time B might also decide, hey, I want to use the medium and transfer some data. So now what's happening actually is that C receives corrupted data because it receives the data from A and B, and this is not good. And the last problem that can always occur when you transfer data is the data might get corrupted while being on the cable due to some external events. For example, if a cell phone is close to the cable, electromagnetic waves might change. The participants should be able to figure this out. And in order to solve all these problems, Ethernet as a protocol was developed. So what Ethernet can do is it can synchronize time intervals. Let's assume computer A sends data at, let's say, 10 megabits per second. And computer C has an interface which allows 100 megabit per second. Ethernet as a protocol will be able to synchronize the clocks between those two devices. Also, it can specify the recipient and the sender. So if A wants to send data for C, computer B will know, oh, this data is not for me, and computer C will know, oh, this data is for me. Also, Ethernet can detect corrupt data. So if data gets sent over the wire and it gets corrupted for some reason, computer C, who was supposed to be the recipient, knows, oh, this data is corrupt. And last but not least, Ethernet can also detect collisions. So if A and C starts to transfer data at the same point in time, they know something went wrong, and C of course gets corrupted data because the data is overlapped by two packages, and we will see in a later video how exactly this works. So I'm Rene Pickhardt speaking, and I hope this video was helpful for you. You learned quite a lot, and in the next video I will explain you how an Ethernet frame is actually assembled and how this will lead to the entire Ethernet protocol. So hope to see you there. Bye bye.